right? So we have CV. Is this in terms of moles or mass? Mass. So I chose to do the moles in this problem. Now what do I need to do? Convert it, right? So how do I convert it? I've written an equation here somewhere, or he said somewhere that you can convert it.
Multiplied by the mole.
Where is the conversion? Right here. So I can simply convert it by saying CV of that mole, or based on kilomoles, for CO2 is equal to CV CO2 multiplied by, like you probably mentioned, multiplied by the molar mass of the weight of CO2. Now, let's make sense of the units here. We got this, what was the problem in, this was 0.657 kilojoules per kilograms Kelvin. Now, the molecular weight, what is that in terms of?
Kilogram per kilomole.
Kilograms per kilomole. So for molecular weight of CO2, it's 44.0 kilograms per kilomoles. So if I take this, multiply it, the kilograms are going to cancel my kilograms, and what am I going to end up with? I'm going to end up with kilojoules per kilomoles multiplied by Kelvin per unit. So what do we get? CV for CO2 is equal to 28.91 kilojoules per kilomole Kelvin. And the same thing I could apply for CV for hydrogen. It's equal to CV of hydrogen multiplied by the molecular weight of hydrogen. Now CV for hydrogen is 10 what? 2183. And that's in terms of your kilojoules per kilogram Kelvin, and multiplied by the molecular weight for hydrogen, it's 1 kilomoles per hydrogen, so multiply by 2, so we get 2 kilograms per kilomoles. So that's going to equal to 20.37 kilojoules per kilomoles Kelvin. So, knowing this, I can, so using equation 3, what am I going to get? I'm going to get T total. So I've already done this for you, and what you're going to get is 308.8 Kelvin. And knowing T total, go back and substitute it in 2 and 1. So solve equation 1 and 2, and what are we going to get is P total is equal to 321.1 kilopascals, and what you're going to get is V total is equal to 79.97 meters cubed. So we got the final temperatures, pressures, and volume. Now what we need is entropy generation, enthalpy, and so forth. The rate of change of entropy is primarily the generated entropy. And that's simply Sgen is equal to the rate of change of that. Now we're going to stop right here and continue it next class. We have that problem so that
Alright, boys.
Bring some blue.
Alright.
Alright.